Determine whether the mean value theorem can be applied to the function f of x equals the square root of x times 1 minus x on the interval, the closed interval 0, 1, and we want to find all the values on the open interval 0, 1 that does satisfy the mean value theorem. Okay. All right, so this is a square root function, right? It is continuous just within this interval 0 to 1. Okay. So yeah, we can use the mean value theorem here. What does the mean value theorem say? It says that f prime of c is equal to f of b minus f of a over b minus a. What does this mean? What is this f of b minus f of a over b minus a? That's just, this is slope, right? It's the rate of change, right? So basically on this graph, right, we're going to take the point at where x equals 0, right, and take the point where x equals 1 on the graph, connect those 2 points together, right? That's going to be a secant line. And then we want to find, well, is there a point on the interior of the function, okay, whose tangent line has the same slope as that? Okay, so that's what the mean value theorem is saying. Okay, so now in no particular order, it doesn't matter which one we do first, but let's just find the rate of change first, right? So what do we want to do? We want to find f of 1 minus f of 0 over 1 minus 0. Okay, so we'll plug in the f of 1 in here, right? So we get radical 1 times 0, which is just 0. Okay, minus, when we plug in the 0 in here, we get, well, we just get another 0, right, over 1. Okay, so radical 0 is just 0, so we do get 0 here, right? So that's the right side, right? Essentially, what does that mean? It means if you connected, right, the 2 points, right, on this graph and drew the line, right, that line, that secant line, will have a slope of 0. So now we want to determine, okay, is there a point on the interior of the function, okay, whose tangent has a slope of 0? Okay, so now we do the left side here, right? So we want to find, well, f prime of c, right? We want to find the first derivative of this guy. Now the c is just a variable, right? So we can replace that with x's with c's here. Okay. All right. How are we going to find a derivative of this guy? And there's a couple things we can do, right? We know that, once again, I'm just going to replace it with c. I'll call these c's here, right? So we could do something like this, right? Call that the 1/2. Okay. 1/2 here, if you wanted to do it that way. And then we can use the power rule along with the chain rule, right? But notice here, right, I also want to distribute through the c, so I'll call it c minus c squared, right? That's going to make it a lot easier, actually, because I don't want to use product rule on this, okay? This is like a polynomial, right? So we just take the derivative of each term, right? So what's going to happen? Right, we'll bring down the 1/2, okay, and then it's times c minus c squared to the negative 1/2. Okay. But then, what do I have to multiply by? By the chain rule, we take the derivative of the inside here, right? Derivative of c is 1, derivative of c squared is 2c, right? So this is our function, okay? Let's rewrite that. We get 1 minus 2c all over 2 times the radical of c minus c squared. Okay. So what does that tell us? It tells us that we have, how are we going to find the critical values, I guess I should say. Well, we said 1 minus 2c equal to 0, right? So 2c is equal to 1. c is equal to 1/2. Oh, that's good, right? That is certainly on the interior of the function. So 1/2 works pretty good. What about other values? Where does this radical c minus, where is this undefined, right? Okay, so c minus c squared is equal to 0. In this case, we get 2 answers, right? We get c equals 0 and c equals 1, but we actually cannot use these, right? Because these are actually on the boundary, right? So we want to find the value of c on the open interval 0 to 1. So in this case, we're going to have that 1 possible critical value here. Okay.